Welcome to Textbook Engineering Problem, where we explore complex engineering problems and discuss different methods for solving them. In this video, I'll be breaking down a problem and discussing different ways to tackle it. However, keep in mind that there is no one correct path for some of these solutions, and I encourage you to share your own insights and thoughts in the comments. Together, we can learn and improve our problem-solving skills. So, sit back, grab a notebook, and let's dive into today's problem. Today we're working out of Elementary Principles of Chemical Processes, 3rd edition, and we're doing problem number 3.49. The problem statement says, a temperature scale that never quite caught on was formulated by the Austrian chemist Johann Sebastian Farblanget. The reference points on this scale were 0 degrees Farblanget, the temperature below which Farblanget's postnasal drip began to bother him, and 1000 degrees Farblanget, the boiling point of beer. Conversions between degrees Celsius and degrees Farblanget can be accomplished with the expression, and then I wrote the expression here. Louis, Farblanget's French nephew, attempted to follow in his uncle's footsteps by formulating his own temperature scale. He defined the degree Louis using, as reference conditions, the optimum serving temperature of marinated snails, 100 degrees Louis, corresponding to 15 degrees Celsius, and the temperature at which the elastic in his briefs began to relax, 1000 degrees Louis, corresponding to 43 degrees Celsius. Part A. At what temperature in degrees Fahrenheit does beer boil? Okay, so 1000 degrees Farblanget equals when beer begins to boil. They gave us this correlation here so that we could convert between Farblanget and Celsius, and then we have this other correlation here that lets us convert between Celsius and Fahrenheit. So we've got a path forward, so we just put in 1000 degrees into this equation, calculate how much Celsius that is, and then we use this equation to calculate how much Fahrenheit. Pretty straightforward for that first part. Part B. What is the temperature interval of 10 degrees Farblanget equivalent to in degrees Celsius, Kelvin, Fahrenheit, and Rankine? Okay, so what you need to be aware of in this part is when you're doing a temperature difference, that's what that delta stands for. You can see here, we've got delta x equals x2 minus x1, so you just put a delta there, so you don't have to write the whole this minus this every time. And x stands for any degrees, C, K, F, R, whatever. Okay, so you can see here, when we're converting between Celsius and Farblanget, we have temperature 1 and temperature 2, temperature 1 and 2, and we've got Fahrenheit or Celsius or Farblanget, whatever. I just put F and C, they can be placeholders. But when you take the difference, you notice that this translational value, it cancels out. So if you do this minus this, the beta cancels out, and you're just left with the scaling factor alpha. Okay, so the only thing that you need to use in this instance, when you're converting Farblanget, is you need to know what the scaling factor is, which is this number. So you scale it just by this number. You don't add 4 because that cancels out when you're doing a temperature difference. Okay, and that means because Celsius and Kelvin are on the same scale, even though they're translated differently between each other, they're going to have the same value. And the same thing goes with Fahrenheit and Rankine. Okay, but we had to scale those using the scaling factor and this scaling factor. Okay, makes sense for part B. See where we got those numbers? Okay, let's move on to part C. Derive equations for temperature in Celsius in terms of temperature in Louis. See example 3.5-1. And temperature Louis in terms of temperature Farblanget. Okay, so they gave us two values in the second half of this equation, and they said that 100 Louis equals 15 Celsius and 1000 Louis equals 43 Celsius. Okay, this, like I said before, you notice that this is a linear equation. We've got slope and we've got an intercept. Okay, they just gave us 2 data points. So now we just draw a line from the one data point to the other data point. So yeah, it's basically a system of equations, 2 unknowns. Okay, so we can easily solve that using substitution, whatever method you want. You could use it linear algebra. I just went ahead and used the matrix method, just did it on my calculator really quick. So, and we solved that the slope is this and the intercept is this. Okay, so that is the relationship between Celsius and Louis. And they already gave us this relationship between Celsius and Farblungit. Okay, so we combine these 2 equations, temperature and Celsius. If we combine these 2 equations and set them equal to each other, then we can have an equation that's in terms of Louis and Farblungit. Okay, and the temperature Celsius will cancel out. Okay, so let's go ahead and combine those. That's what I did here. Combine those, and then we just rewrite the terms so that it says Louis in terms of Farblungit. Okay, so that's it for part C. Part D, what is the boiling point of ethane at 1 atmosphere in Fahrenheit, Kelvin, Rankine, Farblungit, and Louis? Okay, so the boiling point, just look it up in the back of the book, is minus 88.6 degrees Celsius. Okay, we just use our normal conversion factor. I already wrote it earlier, so you should be familiar with how that works, and just plug it in and you get Fahrenheit. Then you do the same thing with our Farblungit equation that we already had, and then you convert it into Louis using the one that we already derived as well. And I just saw that I didn't add Kelvin and Rankine, so let me just add those really quick. Okay, and we just use our conversion for Kelvin and Rankine. If you aren't familiar with those conversion factors, you can just see the previous video where I just wrote them all down there. Let's do part E. What is a temperature interval of 50 Louis degrees equivalent to in Celsius, Kelvin, Fahrenheit, Rankine, and Farblungit? Okay. Remember, you only use the scaling factors, not the translations, because these are delta values. Okay. So we start off with 50, then we use the delta value that we calculated for Celsius, which was right here. Okay. Calculate what that is for Celsius. Then we do the Celsius and Kelvin are on the same scale, so that's easy. Then we calculate what it is for Fahrenheit. We could just use the Celsius one, multiply by 9, divide by 5, get 2.8. And then for Farblungit, we calculated what that was right here. Okay, so, and we get that. All right, that is it for problem number 3.49. Thank you for watching, and I hope you found this video helpful in your problem-solving journey. Remember, there are other routes you can take to arrive at the same correct answer, and I encourage you to leave a comment with any additional insights or questions you may have. Also, if you have any specific engineering problems you would like me to cover, please let me know in the comments. Your feedback is valuable, and I look forward to continuing the conversation with you. Don't forget to like and subscribe for more engineering problem-solving videos. Thanks again, and I'll see you in the next video.